let's say that you were tasked with balancing this reaction up here in acidic solution. The first step would be to separate this equation into two half reactions. And since this is a redox reaction, you should be able to separate it into two half reactions, one of which will represent reduction and one of which will represent oxidation. So in this case, we can split it up like so. We have the iodate becoming iodine, and we have the hydrogen sulfite becoming sulfate, SO4 2 minus. Sorry, my bad, this is a solid. All right, so here we can see that if we look at the oxidation number of the iodate, it actually, or of the iodine in the iodate, it goes from +5, and over here in iodine, it's 0. So when the oxidation number decreases, that means that this reaction represents reduction. Over here, if we take a look at the oxidation number of the sulfur in the hydrogen sulfite, we will see that on this side, it's +4, and on this side, in the sulfate, it is +6. So the oxidation number increases and we have oxidation. And just a side note, if you look at the oxidation number of the oxygen in this equation or in this reaction over here, it actually does not change. It stays at -2. So from this step, the first thing we need to do is we need to balance the atoms other than oxygen and hydrogen in each half reaction separately. So from this point on, we basically handle these two reactions as two separate processes. So over here, we need to add a coefficient of 2 to the iodate. And this is because on the right side of this equation, we have 2 iodine, and here we only had 1, but now with our coefficient of 2, we have 2 iodine on this side on the left as well. And the oxygen is obviously not balanced, but we don't care about that yet. Similarly, on this side, if we take a look at our equation and we ignore the hydrogen and the oxygen on either side of the reaction, we can see that our atoms are all balanced already. So we don't need to do anything to this equation for step 2. In step 3, we need to add water to balance the oxygen, and we need to add hydrogen protons to balance the hydrogen atoms. So on this side over here, we have this reaction. I'm going to erase this to make it less cluttered. So what we need to do is we need to add water molecules to the right side of this equation, because on this side we have 3 oxygens, and on the right side we don't have any oxygen. Sorry, my bad. On this side we have 6 oxygens. We have these 3 multiplied by this coefficient of 2 right here. So we have 6 total oxygens. And we need to have 6 oxygens on the right side as well. So we need to add 6 molecules of water. And the reason we do this is because contained within these 6 molecules of water are 6 oxygen atoms. And so now we've balanced our oxygen. And we need to add hydrogen protons to balance out the hydrogen. So in this case, since we've just added these water molecules, now we have the problem of these hydrogens being here on the right side, but not on the left side. So we have 6 times 2 equals 12 hydrogen atoms on the right side of the equation. So in order to balance this out, we need to add 12 hydrogen protons to the left side of the equation. So we're left with 12 hydrogen protons here, plus our iodate, our 2 iodate, and our iodine, plus 6 water molecules. So for our oxidation half reaction over here, we will perform a similar process. So we have 4 oxygens on the right side of this equation, and we only have 3 oxygens on the left side of this equation. This means that we need to add 1 water molecule to the left side of this equation in order to balance this out. So now we have this oxygen plus these 3 oxygens equals 4 total oxygens on the left side, and on the right side we have 4 total oxygens. And again, just like last time, we've introduced this water molecule, so we have to think about whether or not this hydrogen is going to throw this equation off balance, and indeed it has. We have no hydrogen on the right side of this equation, and now we have 2 plus 1 equals 3 hydrogens on the left side of this equation. So we need to add 3 hydrogen protons to the right side of this equation in order to balance everything out. So step 4 is that we need to add electrons to one side of each half reaction in order to balance the charges. So if we take a closer look at these reactions right here, we'll actually see that our charge is unbalanced. So over here, we have a charge of 10 plus, and we can see that because we have 12 times this 1 plus charge gives you 12, and we have 2 times this 1 minus charge, so we can subtract 2, and that gives us a net charge of 10 plus on the left side of this reaction. And over here on the right side, we don't really have any charge, so this is neutral. So in order to even this out and make this 10 plus charge neutral, we're going to have to add 10 electrons to the left side of this equation, which leaves us with 12H plus aqueous plus 2 IO3 minus aqueous plus 10 electrons. Again, we're trying to cancel out this 10 plus charge so it can be neutral just like the right side of the equation. And that gives us I2 plus 6H2O liquid. Now for our oxidation half reaction, we need to do something similar. If we look over here on the right side, we have a 2 minus charge and 3 times this 1 plus charge. So we have 3 minus 2 equals 1 plus on the right side of the reaction. And if we look on the left side of the reaction, we have this we have a 1 minus charge over here. So on the left side, we have 1 minus. So in order to balance it out, we need to make this 1 plus charge on the right side into a 1 minus charge. And we can do that by adding 2 electrons to the right side of this equation. And this leaves us with H2O liquid plus HSO3 minus aqueous gives you SO4 2 minus aqueous plus 3H plus aqueous plus 2 electrons. So this is where we're at with our oxidation half reaction, and this is where we're at with our reduction half reaction. The next step is that we need to make sure that when we add these two reactions back together, the electrons are going to cancel off. So notice how we have 10 electrons here and we have 2 electrons here. These aren't going to cancel each other out. So somehow we need to make these 2 electrons into 10 electrons. And the way that we're going to do that is by multiplying the whole equation by a factor that will turn that 2 into a 5, or turn that 2 into a 10. So we're going to multiply this whole reaction by 5. And so this leaves us with 5HSO3 minus aqueous plus 5H2O liquid gives you 5SO4 2 minus aqueous plus 15H plus 10 electrons. So now we have 10 electrons in this reaction and we have 10 electrons in this reaction. So we're ready to put it all together. So for the sake of space, I'm just going to erase some things here so we can stack these two reactions and you can see how they go together. And we're going to do something very similar to what happens if you've ever worked with Hess's law. You'll see that we're going to do a pretty similar process in order to stack these two reactions up and kind of add them together, cancel out the identical species, and we'll be left with our final balanced equation. So if we stack our two reactions on top of each other, we're going to have 2IO3 minus aqueous plus 12H plus aqueous plus 10 electrons gives you I2 solid plus 6H2O liquid. And our second reaction was 5HSO3 minus aqueous plus 5H2O liquid leaves you with 5SO4 2 minus aqueous plus 15H plus aqueous plus 10 electrons. And we're basically going to add these up. So as we anticipated and as we needed to happen, we can see that these electrons are going to cancel each other out. We've got some on the left, we've got some on the right. It's an equal amount. They're going to cancel each other off in our final equation. And also, what's going to happen is we're going to see these 15 hydrogens on the right side here cancel off with these 12 hydrogens over here to leave us with 3H plus on the right side because we had more over here than we did over here. So 15 minus 12, we have 3 hydrogens on this side, aqueous. And we're going to see that with our water molecules, we have 6 H2O over here, and we have 5 H2O over here, which is going to leave us with 1 H2O liquid on the right side, again, because we had more on the right side than on the left side. 6 minus 5 leaves you with 1. In addition to that, we're going to see that this isn't going to cancel off with anything, so we're going to have 5SO4, 2 minus aqueous, still on the right side of this equation, and our iodine isn't going to cancel off with anything. So we're going to still have I2 on the right side of our equation. Now moving to the left side, we can see that our iodate and our hydrogen sulfite aren't going to cancel off with anything either, so we just bring them right down into our final equation. And this right here is our final balanced equation. And one way that you can check this equation is by basically looking at the charges and making sure that all of the atoms are balanced. So if you examine this, you will find that all of the atoms in the equation are balanced, and you will also find that if you add up the charges on either side of the equation, they will balance each other out.